Okay, let's tackle these 3.2 notes over logarithmic functions and their graphs. And the two objectives that I have for you by the time we finish these notes is I would like you to be able to evaluate and graph logarithmic functions, and I would like you to be able to solve problems involving logarithmic functions. Okay, so let's look at this gray box right here that kind of defines what a logarithmic function is for us. It says when we have an x that's a positive number, so for x greater than 0, and a base that is greater than 0, a is greater than 0, a also cannot equal 1, we can say that y is equal to log base a of x. And that's true if and only if x was equal to a to the y power. Okay, this function up above here, this function, is called a logarithmic function with the base a. Now, those two equations that I have in boxes in red, I want you to note that those two equations are inverses of each other. Okay. Another way that I have of remembering those two equations that are in the boxes, I'm going to write for you out to the side here. I have that if we have b to the x power equals v. And I use those particular letters because it helps me remember that this is b for base, this is x for exponent, and this is v for value. And when I use those and I switch those over into a logarithmic function, that logarithmic function would look like a log base b of a value is equal to x. Okay, so you're going to see this pop up again later, but this is kind of my mnemonic device to help me remember what goes where. So b for base, x for exponent, v for value. Okay, so when we read a log, we always say, like for instance, this is log base a of x. So this would be log base b of v. Okay, so that way that gives me a chance to remember what goes where when I'm rewriting and converting one from another. Okay, so in your notes, I have a few homework pages attached, not homework, class example pages attached. So we are going to switch up to the page that says graphs 3.2, and I would like to walk through numbers 1 through 8 with you. And then we're going to go ahead and do 9, 12, and 14 also. Okay, so if you notice, this 1 through 8 is going to be a review of section 1.6, so we can see how those things connect, the inverses connect to what we're working on now. So looking at this, okay, we're going to fill in these blanks. It says a function f has an inverse, inverse, if and only if f is 1 to 1. It has to be 1 to 1 or this doesn't work. Okay, it means f will pass, oops, little typo there, will pass both the horizontal and vertical line tests. If it doesn't pass both, it's not going to have an inverse. Okay, the ordered pair x, y on the graph of f gets turned around when it's on the graph of the inverse. So that means it would be the point yx. Okay, if the graphs really are inverses, they will be symmetric across the specific line, and that line is the y equals x line. Okay, for number 4, this is where we're saying that the domains and ranges get shared between the function and its inverse. Okay, so the domain of f is the range of the inverse function, and the range of f would be then the domain of your inverse function. For number 5, if you are algebraically trying to calculate an inverse, okay, to find the inverse function, rewrite your equation replacing your x with y and your y with x. And then you're going to isolate the x by solving, or I'm sorry, isolate the y value by solving for y. Number 6, we did not actually tackle number 6 in our notes. So I'm just going to briefly put in here, draw inverse, but I am not going to teach you those calculator things until later. Okay, number 7, it says if f of g of x is equal to g of f of x, okay, and those both come out to be x, okay, then f and g would be considered inverses. By the same token, if we say f inverse of x equals f inverse f of x would be equal to x, then by the same concept, that same meaning, these guys would be inverses also. Okay, now let's look at a few of these graphing ones. We're going to look at 9, 12, and 14 to start with. So let's circle those. 9, 12, and then 14 will be on my next page. So let's look at number 9. It says graph each basic shape. Okay, and it says it's an exponential. It says, and then we want you to graph its inverse, which is going to be the logarithmic function we're beginning to learn. And then identify the requested information for each problem. Okay, and they want us to show those asymptotes. So let's look at this guy. First and foremost, y equals 2 to the x power. To me, that means I'm going to have this point, because I always have that point when I have an exponential. This guy, and this guy, and he's going to look a little bit like this. Okay, that's my basic shape. And then I'm going to graph my logistic that goes with that. Okay, so my log base 2 of x, you can either type this in the calculator and get a visual, or you can use your reflection line. So y equaling x is this line through here. I should have drawn that dotted because it's just imaginary. So let me hop on that real quick. Okay, that's my y equals x line of symmetry that we talked up here in number 3 about. Okay, and then if I'm going to do a reflection, that means I would have, and I'm going to change colors for my new one so you can tell the difference. My new point, my new point, and my new points. Okay, now looking at the information that they want, let's go through the information for our basic shape first. In our basic shape, our domain is all real numbers. Our range is anything greater than 0. And our asymptote is the y equals 0 line because we're not allowed to cross it. Now, if I'm looking at my new guy, remember your domain and range trade places, just like we talked about up here in number 4. So my domain for this guy should be y is greater than 0. My range would be all real numbers. See how they traded places here, crisscrossed? And then I should have x is equal to 0 because we're not allowed to cross that line at x equals 0. Okay, let's hop down and look at number 12. Okay, y equals e to the x. Again, I'll do my basic shape in red. Okay, I get this point. I have about a 2.7-ish. Remember, exponential curves will always look pretty similar to each other. Just where they're placed on the graph and how steep or how shallow they stay makes a difference. Okay, again, I'm going to have this line of symmetry. My domain, range, and period for this guy are going to be all real numbers. y is greater than 0, and y is equal to 0. No surprise, it's an exponential. It behaves very much like the one in number 9 did. I'm going to switch over to my new color and reflect these points. I was at the point 0, 1, now I'm at 1, 0. I was at 1 and 2.7, now I'm at 2.71. And I was down here at about -1-ish as a mirror image of this point across the line of reflection. Okay, and then those new pieces of information, again, we should have, oh, I have one little typo in the last one I'm going to go back and fix because I just realized it right now. My domain for this guy should be x is greater than 0. That's the one I messed up in the last one. I'm going to come up here and fix it. So, and using my eraser, I'm going to delete this y off of right here. And I'm going to change that to an x. Sorry about that. That was my oversight. Okay, coming back down to this number 12. My range is going to be all real numbers. And my asymptote, the line I'm not going to cross, is where x is 0. Okay, looking at number 14 now. Okay, 14 is just a little bit different. They have a fractional in there, so that kind of affects the way our basic shape is going to look. Okay, so putting a fractional in there, I actually get the 0.01. I actually get -1, 2.7-ish. So my original guy looks like this. That's my basic shape in red. My domain is all real numbers. My range, again, y is greater than 0. My asymptote is at y equals 0. Now let's look at how this changes when we try to reflect across that y equals x line. So here's my y equals x line. And when I reflect that guy across there, some different things are going to happen. Okay, I'm now going to take this point and he's going to look like he's heading up and flat. Oops, one more time. Okay, and then over here is going to be my one that actually crosses over. Okay, so that changes my x domain to be x is greater than 0. My range is all real numbers, and my asymptote is x is greater than 0. So really, that information didn't change. Okay. Okay. So let us continue on with these notes and see what else we need to work on. So I'm going to hop back to my very first page so we can look at some stuff. Okay, so on my first page, a few of the things that we needed to look at when we're talking about the basic shape of a logarithmic function. Okay, there are some general points you need to look at. You have a vertical asymptote, the domain, the range. Okay, it's increasing and continuous, and it reflects across the line. Those are all things that I employed when I was doing those 3 graphing examples with you. Okay. Okay, I am going to hop up to, I think, my 4th page of notes now. And it's this one that kind of looks like Frankenstein got a hold of it because it's all pieced together. Okay, so when you're using a log, it is called a common log if we are using the word log, right? A logarithm with base 10. So log x really means this, log base 10 of x. So if there's no base expressed, we call that our common log, and it's understood to be a base of 10. Okay, if we're talking about a natural logarithm, okay, this is a log, a log with base e instead of base 10. And it ln of x, I know it looks like it's backwards. Natural log is ln. Okay, natural log of x is the same thing as this expression, log base e of x. They mean exactly the same thing. Okay, so when we use that, okay, looking at this definition, if x is greater than 0, then ln of x equals y if and only if this is true. X equals e to the y. And that kind of goes back to my base exponent value setup, okay, where this is my base, this is my exponent, and this is my value. They just use different letters than I do, okay? So if you're using where I just pointed here and comparing it to here, here's the base, e, the value, x, and it equals the f of x, which is the same thing as y, our exponent. Okay, so this is kind of that, the picture if you needed to see the pretty version instead of my just rough sketched reflections. Okay, so this is our e of x basic shape, and this guy is our logarithmic basic shape. Okay, so let's look at a couple more class example graphs, and we're going to go back on that page right above, page 3, I think. And we're going to do 15, 16, 17, and 19 together. Okay, so let's look at those. 15, what did we say? 15, 16, 17, 19. Okay, so if we're looking at number 15, it says identify the equation of the correct basic shape logarithmic function, and then identify any transformation changes that you have, and sketch the graph with asymptotes. Okay, so for number 15, if I'm looking at that guy, my basic shape for this guy should relate to being a log. So this guy's basic shape is going to be y equals log base 5 of x. So basically we just take off kind of like the transformation part, which would be the left, right, up, down stuff. Okay, the part that we used, the change, was inside that parentheses. That makes it a C value, and C values move us left or right. And since it's inside parentheses, we kind of do what the opposite is. It looks like minus, so we move to the right 3. Okay, our basic shape as a logarithm would look like this. And then if we're going to move this guy, and I'm going to use a different color than green, let's go to blue. If we're going to move this guy, we need to move our asymptote. So currently our asymptote is sitting here on the y-axis, but we can't really use that. We need to move it 3 to the right. So 1, 2, 3, this guy, this blue line, is becoming my new asymptote. Okay, and I'm just going to draw that red one, scoot it over 3 units. So I have this, this, and I didn't really leave myself a lot of room, but it's going to sneak right in here. Okay, so just a rough sketch. My asymptote, they wanted me to make sure I include the asymptote, and my asymptote is at x equals 3. Okay, let's look at another one. Let's look at number 16. For this guy, my basic shape is going to be y equals log base 3 of x. It looks to me like the changes, there's two of them. We have a vs of -1 because of this negative sign. And then we have a d value that says we're going to be moving up 4. Okay, our basic shape, same as it ever was. Okay, and now they want us to first vertically flip it, vertical stretch of -1, and then we're going to shift it up 4. So I'm going to use two colors here. My first one's going to be a real light color in between. This is going to be just the flip part. So just the flip part looks like this. Okay, and then I'm going to shift that up 4 units. Okay, so this point goes 1, 2, 3, 4 and becomes here. This point goes 1, 2, 3, 4, about right here. And about right here. Sorry, I got the shakes. My curve looked a disaster there. Let me try to round him out. Okay, and listing the asymptote for this guy. Okay, it looks like our asymptote is going to be at x equals 0. Okay, let's look at number 17. Number 17, if I were looking for a basic shape for this guy, I would be saying that my basic shape is y equals ln of x. Okay, the changes that I think they did to that were two things. I think we have a vertical stretch of 1/2 because of this number sitting out front. And I think it looks like they shifted down 1. Okay, I'm going to start with my basic shape. My basic shape is always the same thing. Okay, we have this kind of traditional look. Okay, you want to use, if you want, you may absolutely use your calculator to do this. Basic shape part, just type it in your calculator and it will graph that for you. Okay, and so now I'm going to do kind of that in-between step where I do half, the VS of half. Okay, that means he's not going to be quite as tall as he is now. So when he comes off of this point here in the middle, he's just only going to be about half as tall as he was before. And it actually doesn't really affect this side too much because it's an asymptote that we're getting closer and closer to. Okay, flipping over to my then blue color to finish up. We need to shift everything down 1. So I'm moving my yellow guy down one, down one, down one, and he's kind of looking like this now. But he's kind of going to end up on top of that red and yellow, so everything's blending there together. Okay, and the asymptote, I hope you guys can find that by now, x equals 0. Let's do number 19, and then we can move on with something new. Okay, if I'm looking at number 19, my basic shape is going to be a y equals log base 1/4 x. And it looks to me like we have two changes. We have a vertical stretch of 3 and a right shift of 1. Okay, so that being said, let's look at this basic shape first. Since it is a fractional base, that kind of reflects our basic shape. So he is going to look like this. Okay, and then we have two things happening, so I'm going to switch to a bright color for this kind of in-between stage. Okay, it says that we can reflect it, and then we're going to shift it. So reflecting first gives me I'm going to have to do a little erasing. I'm looking at the wrong problem. I apologize. I have too many things going on beside me and I looked at the wrong problem. So let me fix something real quick. There's my basic. My intermediate would then be reflected across this line. Oh, I'm still looking at the wrong darn problem. Guys, ignore me for a second while I figure out what I'm doing. Okay, I love erasing because I get to start over. Let's try this one more time. I am doing a vertical stretch, not a reflection. So sorry. A vertical stretch of 3. This guy over here in this location is the one I keep trying to do something else to. Let's focus on him. A vertical stretch of 3 just means that this guy got straighter faster, which it's kind of hard to do because he's already pretty straight. And he went to infinity faster. Okay, now I'm feeling better. And then when we get to this shifting of 1, we can just move everybody out 1 step, which means our asymptote would fall here now at x is 1. And this guy would follow the direction that this poor yellow one was trying to do the whole time I was messing him up. So I apologize for my scattered brain, but that is what I really meant to say. Okay, so now that we have that kind of covered, it looks to me like we are ready to move on to our last page of notes. and it is these logarithmic functions, right? Still, but this is going to be a conversion between log and exponential. Okay, so this is the stuff you're going to really be seeing in your homework. Okay, so I need you to be able to switch between those. Okay, so the purple is the problems directly from the book. I copied them for you so you can see my red star here. That's where we're working from the book on page 203. And I just copied the problems 1, 5, 9, and such from the book for us already. But that's where those purple problems are coming from. They aren't on your page originally, but they came from the textbook. So let's figure out how to convert these things. Okay, so between this, look, here's that BV thing I was telling you about. B stands for base, X stands for exponent, V stands for value. And that's how it converts to a logarithm, and we're going to do some of that. So looking here at number 1, we're going to take our base of 4, goes to a power of 3, and that is going to give us a 64. Okay, now that makes sense to me. Base, right, 4 to the power of 3 is 64. So that makes perfect sense to me. If I take 4 times 4 times 4, I get 64. Okay, looking at number 5, I would take my base number, which is the 32, raise it to the power of 2/5. And if you don't trust me, grab your graphing calculator and put in a 32 and use your caret, and then like open a parenthesis and put 2 divided by 5 as your exponent and hit enter. Guess what you're going to get? This 4 that we thought we were going to get anyway. Okay, looking at number 9. Okay, this says E. Now, if you don't like ln of E and it still makes you panic a little, think of it as log E, right? That replaces the ln of E equals 1. So now if I use that BXV kind of setup, that to me says take this base down here, which is E, raise it to the power over here, and it better equal this number here. Well, I think that makes tons of sense. I think E to the first power does equal E. Number 13. Now we're going the other direction. Okay, they want us to take an exponential and put it as a logarithm. So I'm going to start with the word log. The base of the log is going to be the base number over here. The value has to be next, and that is going to equal your exponent. Okay, I'm going to show you that again with number 17. I'm going to start a log. My base number must be my base on my log. I put in the value, and that should equal the exponent. Okay, if we're looking at number 21, I am actually perfectly okay if you grab your calculator and let's type this in. I want to show you how to do this. So on your calculator, your E button is actually 1, 2, 3 up, actually 2 up from your on button. It's the second function of ln. So you're going to do second function ln. You get an E on your calculator. Okay, and then I'm going to type in a 1.3, and I'm going to let it do all the dirty work for me. Okay, and actually I cheated a little and I already gave you my answer. I think it should equal that. Okay, so basically the answer is kind of there for these first 6, 1, 5, 9, 13, 17, 21. They just want you to like know how you got those answers. Okay, so a little bit of rewriting. Okay, a little bit of rearranging. They just want to make sure that you know how to do that. If I were going to rewrite number 21, I would have ln of the value equals the decimal. So this over here is the actual answer. I'm squeezing him in there. Okay, for number 25, they want us to do this guy, log base 2, and they want us to use a value of 16. So what they're really asking you to do here is do log base 2 of 16, like plug the 16 in. Now, I can show you how to do this on your calculator in a moment, but I want you to think about this. If I had 2 raised to some exponent and it equaled 16, what would that number have to be? So 2 times 2 times 2 times 2 times, how many 2's do I need to multiply together to get 16? I hope you can do that one in your head. I hope you're going to get x equals 4. Okay, so if I'm looking at number 29, same thing. They're giving me a log base 10 of x, and they want me to put a value of 345 in for x. So in solving that, that means I have a 10 raised to some power I don't know, and it has to equal 345. Okay, this is one that I think the calculator should probably be doing for us. Okay, so how are we going to do that? This is a great time for me to teach you how to do the calculator stuff. Okay, I'm going to see if my online calculator will do it, and if not, I'll switch to my camera so you can see how I do it on my actual TI-84. So let's hop over there and see if we can do that. So on the calculator, they want us to do a log base 10 and of 345. Okay, so that's all we're going to do. And when we hit enter, it's going to give us this 2.535. Piece of cake. I'm sorry, 538. Okay, that's all you have to do. So this guy right here comes out to be, this one was 4, this one is 2.5. I'm messing this all up. I'm sorry, guys. Try this again. 2.538. There we go. And that is your final answer for x in this one. Now looking at number 65. Okay, for number 65, they're giving us the same concept. Okay, I accidentally deleted my L when I was erasing above, so I have a negative ln of x, and they want me to plug in a value of 1/2. So in doing that, that is going to now look like a negative ln of 1/2, and I'm just going to type that in my calculator. So on my calculator, I'm going to do a negative ln, and then I'm going to put 1/2 inside that parenthesis. And I should be getting this decimal 0.693. As my answer. Okay, moving on. Let's look at a few of these properties. These properties are the beginning of the properties of logarithms that we're going to expand more next week. Okay, these apply to common logs and natural logs both. So if you can do this with a log, you can do this with a natural log. Okay, this first one says log base a of 1 is always equal to 0. That is because any number to a 0 power is equal to 1. that statement, okay, makes rule number 1 always true. Okay, the property number 2. They're saying if you have log base A of value A, where these two things are matching, okay, it's going to equal 1. And that's because A to the first power is equal to A. Okay, so that's kind of like an identity property for powers. Okay, number 3 and number 4 are actually kind of inverses of each other. Okay, so these two are inverses of each other. Okay, and then number 5 says if log base A of x is equal to log base A of y, then x and y must be the same number. This is true over here for ln's also. Remember I said it's true for one, it's true for the other. So they're saying if ln of x equals ln of y, then x must be equal to y. And we're going to use that property to help us. Okay, let's zip through these last 2 sections and be done. Letter A says we're using these properties up here. So if we have log base 5 of a value of 5, okay, to the power of -2, I'm going to go up and look through those 5 properties and find one that kind of matches this. And when I do that, I am finding that this is property number 3. Okay, they had a log base A, I have a log base 5. Okay, so their AA to the x power is my 5 to the -2 power. Okay, looking at that, that means this log 5 and 5 kind of cancel each other out, and I'm left with a -2 as my final answer. Okay, letter B. This says 4 minus 3 log base 7 of 7. Well, log base 7 of 7 is this part right here, is property number 2. So if I go up and look at property number 2, that says this is a 1. So letter B kind of simplifies to 4 minus 3 times 1. And if I simplify all of that together, I get a value of 1. Okay, if I'm looking at letter C, I'm going to first change this into an exponent instead of a root. So this guy right here is the same thing as saying ln of e to the 1/2. Exactly the same thing. And now if I look up at my rules, this is rule 3, where I have ln and e raised to a power, so my answer must be whatever that power was. So my answer is 1/2. Letter D uses property number 1. Log base A of 1, right, is equal to 0. So that must mean 6 times 0 equals 0. Letter E, it looks to me like this is m to a power, so that looks like property 3 again for me. The log m to the value m kind of cancel each other out, and that leaves me with 3x plus 2. Since I can't simplify that anymore, it's my answer. Okay, number F. They have an ln of e. I'm going to go over here. My ln property says property number 2, ln of e is equal to 1. And I'm done. Letter G. Log base 10 is equal to 1. Well, here's a log base 10. So what this is really telling me is to take 2 times 1, which is 2. Now I accidentally wrote over this, so let me delete something real quick. I have ln e of 2 minus x. If I am looking at property 3, ln e over here, towards the end of the property, L and E reduce each other out, that means I'm left with the 2 minus x. That can't simplify anymore, so I'm done. Okay, I'm going to skip this guy here, and we're going to hop down and see how we do some solving using these properties. Okay, so here's a couple hints for you. Strategies for solving. If both sides of the equation have a single logarithm and the same base, this is your best case scenario. You're just going to drop off the logs and solve. So let's look at letter I. They are both a single log. They both have the base 6. I'm going to drop the log, and I'm going to have x equals 8 to the 2/3 power. Okay? Now, the reason that works is because of property 5. Property 5 said if log ax equals log ay, then x and y had to be the same value. Okay, now we're not going to leave letter I like that. We're going to simplify it out. Yes, you may grab your calculator, but we can do this logically. This becomes a cube root of 8 squared. The cube root of 8 is 2, and 2 squared is 4. But yes, you may type it right in your calculator as 8 to the 2/3 power. Okay, looking at letter J, it looks to me like I have the same thing going on. I have log base 8 and log base 8. So I'm going to set 4 equal to x minus 3, and I'm going to solve for x. Okay, letter K. I don't have a log on each side, so this doesn't fit this part A strategy. So we're looking at the part B strategy. If one side of the equation has a logarithm, which it does in letter K, and the other side is a constant or an expression, which ours is, use one or both of these techniques. Use your log properties to simplify, and then rewrite the logarithmic expression as an exponential expression. Okay? So, I don't have a logarithm on both sides. I'm going to use this strategy. Says use log properties to simplify. My log property says I'm going to take the base, raise it to the x, and set it equal to the value, which here in the box was the value for this problem. Well, looking at this, it is very, very easy to see that x has to be 4. Okay, they both had a base of 3, and they should be raised to the same power to keep them equal. Okay, if I'm looking at letter L, okay, analyzing this one, I don't have a log on both sides, so I'm using strategy B. I'm going to use some log stuff to simplify. Okay, so I'm going to have e to the 4th power equals e to the x, and I got that because remember, this is the same thing as saying log base e of a value is equal to 4, so base e raised to the 4 equals the value, and the value happened to be e to the x. So I took this guy raised to this guy equals this guy. Okay, and then when I solve this, it's clear since they're both an e raised to a power, x must be 4. Okay, looking at letter M, I'm just going to rewrite this a little bit. ln is going to stay put, but instead of having 1 over e, I'm going to put e to the negative 1 just a quick way to rewrite something so it's not fractional, but it does have a nice exponent that we can look at. This goes back to our log properties. If we have an ln of e, it's like the L and the E kind of reduce each other out, and I'm left with x is going to be -1. Okay, last problem. For letter N, I'm going to do a little bit of rewriting, okay? Since I have a log on both sides, those are going to drop out, right? Drop the log. That leaves me a 4 equals 3x squared. Okay, in solving this, I'm going to move my 3 to the other side and get 4/3. I don't want x squared, I want just x, so I'm going to square root both sides. That's going to give me a positive or negative square root of 4/3. And I'm going to let you leave it just like that and not even make you reduce it from there. Okay, I hope these logarithm notes have been helpful.